conic sections. In this section, we will talk about, in detail, the parabola, the ellipse, and the hyperbola, showing how to sketch them, how to work with them. This should not be anything different than what you've probably learned in a pre-calculus course. And it's just a review of these topics. They are needed, and you'll see them again in Calculus 3, so we're just going to do a quick review of them. All right, so first, the parabola. A parabola is a set of points in the plane that are equidistant from a fixed point F, which we call the focus, and a fixed line called the directrix. The point halfway between the focus and the directrix lies on the parabola, and it's called the vertex. In general, an equation of a parabola with focus 0p and directrix y equals negative p is given by x squared equals 4py. So that is these cases. X squared equals 4py. And if p is positive, the parabola opens up. And if p is negative, the parabola opens down. If we have a parabola with focus at p0 and directrix x equals negative p, the equation is given by y squared equals 4px. And that's these examples. Notice that if p is positive, then the parabola opens right, and if p is negative, the parabola opens to the left. Suppose we were asked to find the focus, vertex, and directrix of x equals negative 5y squared. All right, so I'm going to write this in the form y squared equals 4px. So that's the goal here. If I can write it like this, then I can figure out some information. All right, so dividing through by negative 5 or multiplying by negative 1/5, I can write that y squared is negative 1/5 x. So now I need this negative 1/5. That negative 1/5 needs to be 4 times, so 4 times p is equal to the negative 1/5. And so multiplying by 1/4, p is negative 1/20. So what that means is I can write this equation as y squared is 4 times negative 1/20 times x. All right, so what does that tell me? Well, the vertex is 0, 0. Since there are no shifts in this, and we'll talk about shifts in the next slide. Now, since the p-value is negative 1/20, then the focus is p0. Right? How do I know it's p0? Since there's a y squared equals 4px, I know that it's opening left or right, since it's got the y squared. All right, I know it's one of those cases, and then since the p is negative, I know it's opening left, and so the focus then is negative 1/20, 0. The directrix would then be x equals positive 1/20. All right, so basically what we're saying here is we have a directrix at x equals 1/20, and we have a focus at the point negative 1/20, 0. We can shift parabolas by taking the standard equations and replacing x and y by x minus h and y minus k, respectively. And so then we can have the equation x minus h squared is 4p by y minus k, or y minus k squared is 4p by x minus h. So for example, if we're asked to find an equation for a parabola with vertex at 1, 0 and directrix at x equals -5. Well, if we're asked to just find the equation, we can do that. It might be helpful to sketch it to see what happens. So if we have the vertex at 1, 0, and the directrix is at x equals -5, so there's the directrix. And so now what I like to notice is, well, what's the distance between the directrix and the vertex? That's 6 units. So then the focus is 6 units inside here. And so if you just wanted a rough sketch, right, you'd have a parabola opening to the right, something like that. But also notice that that tells me that the p-value is 6. All right, so we have it just shifted to the right, so that affects the x. Since it's opening to the right, that's going to be of the form y minus k squared is 4p times x minus h, right? If it opens left or right, we have a y square. And so then the equation would be y squared, since we're not shifting the y at all, equals 4 times 6 by x minus 1. So y squared is 24 by x minus 1. Alright, now moving on to the ellipse. An ellipse is a set of points in the plane, the sum of whose distances from two fixed points, f1 and f2, is a constant. The two fixed points are called the foci. So, in general, if we have the equation of the form x squared over a squared plus y squared over b squared is 1, where a is greater than or equal to b is greater than 0, we'll have foci at plus or minus c, 0, where c squared is a squared minus b squared. The vertices are at plus or minus a, 0. All right, so if we have, in general, right, if we have we want to figure out which is the greater of those perfect squares, or those squared quantities. So here, if we have the x associated with the a, which is the largest number, we say that this has a horizontal major axis. Whereas in the second example here, if we have x squared over b squared plus y squared over a squared is 1, again, where the a is larger. And what happens is we get a vertical major axis. But again, the foci are now on the vertical axis, and so would have the ordered pair 0 plus or minus c. Again, where c squared is a squared minus b squared. And the vertices, again, notice, are vertically changed from the origin, so 0 and plus or minus a. Find the vertices and foci of the ellipse x squared plus 4y squared equals 4. All right, to put this in one of the forms that we're used to seeing, that was just explained in the previous slide, I'm going to divide through by 4 to make the one side equal to 1. So now I have the equation x squared over 4 plus y squared is equal to 1. And I can think of that y squared as a y squared over 1. And so now I look at these and I say, okay, well, the 4 is 2 squared and the 1 is 1 squared, and 2 is greater than 1. So, since 2 is greater than 1, what that tells me is I have a horizontal major axis. Right, because the 2 is associated with the x. So I have a horizontal major axis. And so then the vertices are at plus or minus 2, 0. All right, what about the foci? Well, we need to figure out what is this c. And c squared is a squared minus b squared. And so then c squared would be 4 minus 1. C squared is 3. So then C is plus or minus root 3. And so then the foci are at plus or minus root 3, comma 0. Now, if you wanted to sketch this ellipse, I'll just do a rough sketch. Its center is at the origin, since it hasn't been shifted. We'll talk about shifts in the next slide. The major axis is horizontal with vertices at plus or minus 2. So we have a vertex here and we have a vertex here. Now, if we look at the y's, notice we have a y squared over 1. And so then, in a sense, what makes that term go to 1? If x was 0, we would have points at 0 plus or minus 1. The foci are at plus or minus root 3, and root 3 is about 1.7, so foci, I'll use open points because the curve does not pass through those points. And so we get a shape that looks something like this. So there's the graph of x squared plus 4y squared equals 4. Find an equation for an ellipse with foci 0 plus or minus 4 and vertices 0 plus or minus 5. Alright, so since it has vertices at plus or minus 5 and foci at plus or minus 4, what this tells me is I have a vertical major axis and also it tells me that since it's a plus or minus 5, that tells me that the a value is 5. With foci at plus or minus 4, that tells me that the c value is 4. And so then, using the fact that c squared is a squared minus b squared, I find that 16 is equal to 25 minus b squared, which implies that b squared is 9, which implies that b is 3. Right, and so it has a vertical major axis. So I know I need so let's say I've got an x squared over something, I've got a y squared over something equals 1. Alright, now I've just got to figure what goes under the x squared and the y squared. Alright, so under the y squared, since it's a vertical major axis, we would need a 25. That's the a squared. Under the x squared, we would put the 9. That's the b squared. And so x squared over 9 plus y squared over 25 equals 1. And if we wanted to then sketch it, alright, since we have x squared over 9, that would tell me that the curve goes out to plus or minus 3 on the horizontal axis. And so we get, there's our ellipse. We can shift ellipses by taking the standard equations and replacing the x and y by x minus h and y minus k respectively. So for example, suppose we wanted to find the equation for an ellipse with foci at 0, 1, and 8, negative 1, and a vertex at 9, negative 1. Alright, so let's see, I've got foci at 0, 1, sorry, that should read 0, negative 1. Foci at 0, negative 1, and 8, negative 1, and a vertex at 9, negative 1. Well, if I've got a vertex at 9, negative 1, then the other vertex should be at negative 1, negative 1, just by the symmetry of the curve. Alright, so let's see. Notice that this is not on the x-axis or the y-axis. It does have a horizontal major axis. Alright, so we know that. Now, what's the center? Well, the center is going to be halfway between the foci, and so then the center is going to be at 4, -1. All right, and let's see, what's the distance from 4 to 9? That's a distance of 5. From 4 to 8, that's a distance of 4. So I know that A equals 5 and C equals 4. So like in the previous example, we can then find that B equals 3, using the fact that C squared is A squared minus B squared. All right, so now let's see, I'll have instead of x squared over 25, it's been shifted to the right. So we will write x minus 4 squared plus something over 9. Instead of a y squared, it's been shifted down. So we will write y plus 1 squared. So x minus 4 squared over 25 plus y plus 1 squared over 9 is 1. A hyperbola is the set of points in the plane, the difference of whose distances from two fixed points f1 and f2 is a constant. So, in general, the hyperbola x squared over a squared minus y squared over b squared equals 1 has foci at plus or minus c, 0, where c squared is a squared plus b squared. All right, so for the hyperbola, it's an a squared plus b squared, whereas for the ellipse, it was a squared minus b squared. Has vertices plus or minus a, 0, and asymptotes plus or minus b over a times x. Now, the way I always remember this is, if we look at the coefficients, whichever one is positive, right? So here we have the x squared over a squared, that's positive. And so it opens left and right. Whereas, if we have a y squared over a squared minus x squared over b squared, this will open up and down. But otherwise, pretty much the same. The foci, you find the c, where the c squared is a squared plus b squared. And the vertices, since it's opening up and down, are vertically moved from the origin or from the center rather than horizontally moved. Find an equation for the hyperbola with foci at plus or minus 6, 0, and vertices at plus or minus 4, 0. All right, let me just do a rough sketch. Let's see, the vertices are at plus or minus 4, and so vertices, those are solid points on the curve. Foci, I like to use open points on the curve. All right, so what this tells me is I have something like this. All right, and let's see, the vertices are at plus or minus 4, so that tells me that the a value is 4. The foci are 6 units from the center, so that tells me that the c value is 6. And for the hyperbola, c squared is a squared plus b squared, so then 36 is equal to 16 plus b squared, and b squared is 20. Since it's opening horizontally, it's opening left and right, I know it's going to be an x squared over a squared minus y squared over b squared equals 1. So we'd have x squared over 16 minus y squared over 20 is equal to 1. As with parabolas and ellipses, we can shift hyperbolas by replacing x and y with x minus h and y minus k respectively. So, for example, let's find an equation for the hyperbola with foci at 2, -2, 2, -2, and 2, 8, and vertices at 2, 0, and 2, 6. So since those are the vertices and the foci are in a sense inside, we have a curve that does something like this. All right, so where's the center? Well, the center would be at the midway point of either the vertices or the foci. So I think this would be the center. All right, so I know I have a center at 2, 3. The distance from the center to the vertex is 3, and so that's my A value. The distance from the center to the focus is 5, and so that's my C value. And using the fact that C squared is A squared plus B squared, then 25 is 9 plus B squared, and what B squared is 16. Alright, so since the center is 2, 3, and it's opening vertically, that is up and down, so I'd have, generally we would have had a y square over 9, over a square, minus, let's see, x squared over, what was b, 16, equals 1. But since it's been shifted, we have to take into account the shifts. And instead of y squared, since the center is 2, 3, we'd have a y minus 3 squared. And instead of x squared, we'd have an x minus 2 squared. Finally, we'll end the section by looking and identifying types of conic sections just by looking at the equations. Some of them are relatively easy to figure out. Some of them are a little tougher. But ultimately, what you want to do with these is to look at the square quantities. If there's only one square quantity, we know that the only possibility there is a parabola. If there's two square quantities, then look at the coefficients on the square quantities. If they have the same coefficient, that would tell you that it would be an ellipse. I should say same sign. If there's the same sign on the coefficients, that tells you that it's an ellipse. Whereas if you have different signs on the coefficients, that would tell you hyperbola. Alright, so for example, we have y squared plus 10x equals 0. I only have one square quantity, so therefore this is a parabola. I have on the second example, I have a 9x squared and a 16y squared. Same signs, that's an ellipse. Whereas if I had 9x squared minus 16y squared, since they have different signs, that would be a hyperbola. In the fourth example, I have a y squared, and that's the only squared quantity. That's a parabola. (25x squared) and a 4y squared. That would be an ellipse. And finally, I have a 4x squared and a negative 3y squared. That would be a hyperbola. Now, if we wanted to go further with those, like let's take, for example, this last one, this hyperbola. If we wanted to go further and get some understanding of what the graph looks like, then we have to do some completing the square to put the curve in that standard form. So let's consider that example. Alright, so let's take that last one, let's put it in the standard form, and what I'm going to do here is I'm going to group all of the x's together and the y's together. So let's see, I'd have a 4x squared plus 16x, and then let's see, I'd have a minus 3y squared and a plus 18y, and I'm going to bring that 1 to the other side of the equation as a negative 1. I do some factoring here. So I'm going to write the x's as 4 times x squared plus 4x, and I'll leave some space there. And then I'll have minus 3 times y squared minus 6y, and I'll leave some space there. This is still equal to negative 1. Now, completing the square on the insides. Let's see, x squared plus 4x, I would have to add 4 to complete the square here. Now understand what I've just done is I've added 16. Right? I've added 4 times 4, I've added 16, so I have to subtract 16. On the second grouping, y squared minus 6y, I would have to add 9 to complete the square. And notice I've, in a sense, just subtracted 27. Negative 3 times 9 is 27. I'm sorry, I should have added 16 earlier. Right, if I add 16 on one side, I have to add 16 on the other side. Now here, negative 3 times 9, negative 3 times 9 is negative 27. I would now have to subtract 27 on the right. Alright, so let's see what happens here then. I would have 4 by x plus 2 square minus 3 by y minus 3 square is equal to negative 1 plus 16 minus 27. That would be a negative 12. Now I want to get the right hand side to be a negative 1, or to be a 1. So I divide through by negative 12 each term. Alright, so dividing through by the negative 12, I would now have negative x plus 2 square over 3 plus y minus 3 square over 4 is equal to 1. And we would normally write this as y minus 3 square over 4 minus x plus 2 square over 3 equals 1. And so now we could use that information to sketch the curve appropriately. Alright, that concludes this presentation.